So in this problem, we need to find out the cosine of angle A in a triangle ABC, whose coordinates of the vertices are provided to us. So let us begin. Now here, we have the triangle A, B, and C. So A has the coordinate value 1, 1. Then we have B. B has the coordinate value 4, 5. And then we have the vertex C with coordinate 6, 13. Our goal will be to find out cosine of angle A here. So let's first specify the cosine formula. Let us suppose that we have a triangle with vertices given by A, B, and C. Now what we'll do, we'll consider the side opposite to angle A, which is BC, and when represented by the letter A in lowercase. Then we consider the side opposite to angle B, which is AC, and denoted by the letter B in lowercase. And similarly, we're going to consider the angle C and the side opposite to it, which is AB, represented by the letter C in lowercase. Then the cosine formula states it is, let's say, if we take cosine of angle A, all we have to do is we'll have to form a ratio such that in the numerator, what we'll do, we'll consider the sides adjacent to angle A. So that is B and C. So what we'll do, we'll take angle side B, square it, and add it to square of the other side, which is C. So we have B squared plus C squared. And from this sum, we're going to subtract the square of the side opposite to angle A, which is A. So we have A squared divided by 2 times B times C. So this is how we can define cosine of any angle. Similarly, we can also find out cosine of angle B. So let me note that down. The cosine of angle B will be simply, all we have to do is consider the sides opposite adjacent to angle B. So that's A and C. We have C squared plus A squared minus B squared divided by 2 times CA. Now in a case, what we'll do, we'll consider our triangle. So in triangle ABC, so we have to find out cosine of angle A. So what we need is the side which is adjacent to angle A. So that's AC. So we'll take AC, square it, and add it to the side, square of the side adjacent to it. It is AB. So we have AB squared. And from these two sides, square of these two sides, we're going to subtract the sides opposite to it, which is simply BC. So we have BC squared divided by 2 times AC times AB. So now our goal will be to determine the value of AC, AB, BC. That means the sides of the triangle. For this, we'll be taking the help of the distance formula. So let's use the distance formula. We'll start with, let's say, AB. So AB is given by, so we'll have to take the square root. So first, what we'll do, we'll take the difference of the x coordinate, square it, and add it to difference of the y coordinate and square it. So difference of the x coordinate means, so since we have AB, so we'll start with B first. We'll consider the x coordinate of B. So that's B 4, and from it subtract the x coordinate of A. So that's going to be 1. So we have 4 minus 1. We are going to square it and add it to difference of the y coordinate. So we'll start with the y coordinate of B. So that's simply 5. And from it subtract the y coordinate of A. So that's 1. So we have 5 minus 1 squared. So let's find out the value. That is going to be equals to square root of. So 4 minus 1, that's 3. 3 squared is 9. Plus 5 minus 1, that's 4. 4 squared is 16. So 9 plus 16, that's 25. That means we have square root of 25, which is simply 5. So that means length of side AB, so that's 5. Fine. Now coming to side BC. So BC will be equals to, we'll use this distance formula. Since we're doing BC, so we'll have to do C minus B. That means we'll start with the x coordinate of C, which is 6. From it subtract the x coordinate of B. So that's 4. We have 6 minus 4, square it, and add it to the difference of the y coordinate. So that's 13 minus 5. So we have 13 minus 5, and then we're going to square it. So this is going to be equals to, so we have square root of, so 6 minus 4, that's 2. 2 square is 4. Add it to 13 minus 5, that's 8. 8 square is 64. So we're going to get square root of 68. And then let's find out the value of CA. So CA is going to be equals to, we'll take the square root. Since we're doing CA, so we'll have to start with the x coordinate of A first. So that's 1 minus x coordinate of C. So that's 6. So we have 1 minus 6 whole squared. And then we are going to add to it the square of the difference of the y coordinate. So that's going to be 1 minus 13 whole squared, which will be equals to, so we have square root of, so 1 minus 6 squared, that's 25, because that's negative 5 squared, which is 25. And 1 minus 13, that's negative 12. Negative 12 squared is 144. So 25 plus 144 is 169. So that means the square root will be 13. So now we have obtained the value of AB. So and BC. BC came out to be square root of 68. And then we have the value of CA, which is 13. So we can substitute all this value back in this particular equation. Let's call it equation number 1. We will be able to find out the value of cosine of angle A. So cosine of angle A will then be equals to AC squared. So AC, that's 13 squared, which is simply 169, plus AB squared. AB squared is 5 squared, so that's 25, and minus BC squared. So BC squared is square root of 68, and squaring it simply gives us 68 whole divided by 2 times we need AC. So what's AC? AC is 13 times we need AB. So AB is 5. So we have 2 times 13 times 5. Okay, so this will be equals to, so 169 minus 68, so that's going to be 101. So 101 added to 25 is 126. Divided by 2 times 5 is 10, 10 times 13 is going to be 130. So if we further simplify this, we're going to get 63 over 65. So that's the value of cosine of angle A. So let's check which option corresponds to 63 over 65. So that's going to be option C.